Good morning, all. My name is Mujibur Rahman, as I was introduced. So I'll share my screen. Okay, so I'll just go through the introduction first. So as I said, my name is Mujibur Rahman. You can call me Mujib. I have over 7 years of experience in JavaScript development or web development. So I work with product-based companies where I get a chance to work with R&D department. So when you say R&D department, that's where the projects would be challenging. And I got to learn the modern development practices, and that's what I'll be sharing. So where I have over 4 years of experience in training. So I'm a web developer and trainer. So training is my passion. So I'd like to share my knowledge, whatever I've gained from my experience. So this is not going to be a bookish knowledge where I read somewhere and then I delivered it. Rather, it is something that I worked, I have experienced, and then I try to share it. So apart from this, I got a chance to work with many technologies such as Java, C Sharp, Python, and JavaScript, and then Scala, and then Rust. So, and apart from this, I worked with mobile development also. So a few technologies. In product-based companies, what happens sometimes you need to switch the technologies based on the project needs. So in my 7 years of experience, I ended up working with many technologies. So how do I learn all these technologies? It's because I focus on concepts instead of focusing on particular technology, because the concepts are going to be same for all of them. Okay, so what is the agenda for today's session? So in today's session, I'll try to go over very basics because I assume you all are college students. I don't think anybody is experienced here. Let me know if someone is having any experience. So we'll try to go over basics of computers, like what are they, and then we try to understand what is programming, why do we need to learn it, and then we'll try to jump into a little bit of JavaScript introduction. And before that, we'll try to talk about what is actually MERN and what is the industry standards today and how the industry is moving as far as MERN is concerned. So yeah, hopefully that will take an hour, and this should definitely, they should not teach you entire MERN in one session. That's impossible, but at least this gives you an idea like how my teaching style is going to be and whether it fits your need or not. Because this is a demo session, this helps you decide whether you can achieve your goal or not. As I just said already, one thing that is expected from every candidate is commitment. So if you're not committed, no matter like how great institute you join, definitely the results are not going to be great. So one thing is expected from youngsters is you are committed to something. So if you're joining something, you're putting your money, you're putting your effort. So the commitment has to be there and the effort needs to be put. Okay, any questions before we get started? So feel free to stop me. Do not hesitate to stop. I would love to answer your question if you have any. Of course, we have a dedicated Q&A session after this, probably at 10 o'clock. But in the meantime, also, if you have any questions, concerns, feel free to put them forward. Okay, so what is MERN? MERN is MongoDB. It's just an acronym. You have Express.js and then React and then Node.js. So this is called full stack development. So what is full stack? It's actually today web developers don't write one application, rather they write two applications. We call them front end and then back end. So that's what full stack means. So a developer who can write front end and back end is called a full stack developer. So there are front end developers, they only know full stack, they only know front end development like React, or there is alternatives like Angular and Vue. And then there is back end development who can write only back end, like using Node or Java or C Sharp or Python and various others like PHP, all those. So Node and React is what we're going to learn in this course. So MongoDB is the database because you need a database to save something. So if you don't understand what is database, why do we need all those things, don't worry about it. We will definitely come to that point. But having said that, MongoDB should not be the only database that you need. It can be others also. But this course focuses on MongoDB. Once you are done with this course, you are free to give interviews in any database. You are free to use any other database. Like, what are the other databases available? There is PostgreSQL available, there is MySQL, and there are a lot of others like Oracle and so on. So there are n number of databases. You can use it. So, as I said, I expect commitment from you, but what is the outcome? So, what are you going to get if you give time and money? So, I wouldn't say you'll get 100%. I can guarantee you that you get a job. As I said, it's again depends on your effort. So, I'll try to deliver from my side. And when you put your effort, the expectation is you crack product-based company interviews. So what are product interviews? Actually, there are three types of companies: tier 3, tier 1, and tier 2. So tier 3 companies are like service-based companies. In fee, you have TCS, and you have Wipro, and so on. So these interviews are relatively easy to crack, and sometimes even if you don't know programming, you will be able to crack these interviews. So as I said, they are relatively easy interviews to crack, and definitely they're not going to pay you much, and their salary is around 3 lakhs per annum. So what do you mean by 3 lakhs per annum? That usually the packages are in annually they are termed. So 3 lakhs per annum, around you get 18,000 per month would be your take home salary. So it's not a great amount, not a great like place to be in. And definitely most of the campus placements happen through these companies, and they just hire many candidates irrespective of their background. It may be civil engineering, it may be electrical engineering, or even computer science. No matter what, their package is same. It's 3 lakhs per annum. So if you go back and check 15 years ago, and 15 years ago also they paid 3 lakhs per annum. So in 15 years, they haven't changed really any amount. So if you consider today's inflation, 18,000 salary is not a good salary at all. Okay. So tier 2 companies are nothing but product-based companies. Like you talk about ServiceNow, you talk about say ADP or CDK, or you can name, there are thousands of companies in Hyderabad alone. And these companies pay you around 8 to 13 lakhs per annum. This is a great salary. Like your take home salary would be from around 50K to around 1 lakh. So monthly salary I'm talking about. So this is where we will be targeting. And if you can focus on it, this is where these are the interviews that you can crack. So there are tier 1 companies, like top 4 we call them, that is Amazon, Apple, and Microsoft, and Google. So of course there is a Facebook also. Yeah, these companies definitely they pay you around 13 to 20, 25. It depends again on your college background and all those things. And these are relatively complex interviews, and they are very hard to crack unless you dedicate your 6 months of time. You will not be able to crack these interviews. So this is where we will be focusing on. And if you learn MERN, and somewhere around you will be there. 8 to 13, that's 8 is usually that's their starting package, and definitely it's a very respectable package to have, because when you're getting 50K salary, that's pretty good amount. Of course, ServiceNow pays 13 lakhs for freshers. As I said, the more higher the amount, definitely the interview would also be complex, and they expect you to be something known as a problem solver. So what do you mean by problem solving? It's nothing but there is a real world problem and you solve it. For instance, if you know Ola or Uber, they're solving a real world problem. So if you go back and check like 5 or 6 years ago, you have to order a taxi, or you have to call a taxi and then book it, and you don't know where the taxi is, and you don't know when it will arrive, and all those things. So Uber has sensed that problem, so they have written an application, and now you can book a cab, you can see the cabs around you, and you can see where the driver is, and you can see when the driver is going to arrive, which route the driver is taking, and how much money you're going to pay, and what is the distance, all these things. So that's a real world problem, and you have solved it. So who solved it? Someone like you at Uber, who are employees, who are professionals. They solved it. And that's what problem solving means. So there was a real world problem and they solved it. How did they solve it? It's definitely a complex problem to solve. They use Google Maps to find out the locations and distance and all those things. And they use GPS to track the driver and so on and so forth. But no matter what, end of the day, it's still programming and computers. So will you be there? Definitely. Again, with the hard work, you can be there. You can definitely join Uber. Hyderabad has an Uber office. You can join it, but a bit complex. So any questions so far? So this is the background, and this is where at least you should try to be. Yeah, this is a great place to be in, but with a lot of efforts. But this is relatively less efforts. You can be here. And if nothing, of course, nothing works out, probably you will be end up joining a tier 3 companies. And I wouldn't recommend you to join it, but if you don't have any job offer, yeah, if you get a job, definitely something is better than nothing. So you will join it. But this should be your focus to join tier 2 companies. Yeah, let me know if you have any questions before we get into actual demo. So this was just setting up a pace or setting the expectations. So I'll stop my videos so that I don't create any connectivity issues and we can focus on the actual demo. Okay, so as I said, I see most of you are freshers. So I thought it's a good idea that we start from very basics. If you already know this, you may seem a little bit, you may feel it is a little bit boring. But if you don't know, this would be a great learning. Just bear with me either way. Okay, so what is a computer? As I said, computer is a device. So, and you do programming on it to solve real world problems. But when you go and dig deeper into it, see the actual programming, when you see it, it boils down to two things. One is save the data and perform the operations on the data. You take any problem, this is how it's going to be. Like, for instance, you're building a college management system. So what you should do, you should save the students' information and then you perform operations on it. What kind of operations are we talking about? Say a student is paying a fee. So saving his fee or modifying his, maybe his details for some reason, if they are wrong, modifying it. So you're kind of performing operations on his data, or you're promoting him for the next semester, or you are providing his results, or you're saving his results, and so on and so forth. So it all boils down to do these two things. One is you save the data. Another one is you retrieve the data and you perform operations on it. So for that purpose, we use computer devices. And if you go deeper into it, how does computer saves the data? So for that, we need to understand a bit. Like, so if you say this is a computer device, you have something known as a processor. And then you have, say, RAM. So the organization, I'm just putting the boxes here. Don't assume that this is how the organization is going to be. It's actually, you have a motherboard and that's where you fix everything. But just for understanding purpose, I'm putting these things here. And then apart from this, you have something known as a disk space, or we call it hard drive, or now these are SSDs. No matter what, the right term to use is disk. That's the generic term. So these are the three important things that you have. Definitely there are other pieces, but we are mostly interested in these things as a programmer: processor, RAM, and disk. This is the same thing even for your mobile device, because your mobile device is also a computer today. It is no different. You take it a mobile device, you take your laptop. So you have these three things. And this processor is also called CPU. So most of the time people assume that CPU means that big box that they put it just next to the monitor. That's not the case. CPU is actually a processor, central processing unit. It is the heart of your application. So in interviews, questions like basic questions comes because they test your fundamental knowledge. So the more fundamentally you're strong, the more smart or more mature developer you would be. So without even knowing what is a processor, you can still learn Java, you can still learn programming, and you can still write programs, but you will not be matured enough. So I myself take interviews in my company. So we try to test candidates with their basics. Like I ask questions like how do you measure the capabilities of a processor? Yes. So how do you tell your friend that you have this much of capability or processing power? Anyone want to give a try? So how do you measure? How do you tell your friend that you have this much of processing power? So you can put it in the chat window, or you can unmute yourself and talk. How do you say that I have this much of processor? Yeah, try finding a chat window. And if you can find it, try to put it in the chat. See if you get it right. It's okay if you get it wrong. That's fine.
By
No issue.
seeing the properties or in the buyer setup.
No, the capability. Say, how much RAM do you have? How do you say that?
By looking to the system, I mean checking to the system.
Yeah, checking to the system. But in general, how do you say that? How much of RAM you have in your mobile?
Like generally,
Yeah, generally. So how much RAM
generally
you have in your mobile?
8 GB RAM or
Right,
16 GB
that,
RAM.
right? You say it's gigabytes.
Yeah, yeah.
And then how do you say how much processor you have in your mobile or in your computer? So something like this, gigahertz, it's frequency. So you say 1 gigahertz. So the question comes even more deep now. So what do you mean by 1 gigahertz? So how do you measure? I'm just going to keep everyone mute just to not let this session jeopardize. So this section, I believe this session is getting recorded, so to avoid noises. So if you have any questions, you can unmute yourself and ask. So how do you say that my processor has this much of capability using gigahertz? Or yeah, a decade ago it was megahertz. But anyway, we have come a long way now, 1 gigahertz. So the interviewer asked you, what do you mean by 1 gigahertz? So what do you even mean by 8 GB? So of course, the disk space is going to be a little bit bigger than RAM. So it would be like, say, 128 gigs or 256 gigs. And if you take the computers, it would be around 1 TB or 2 TB. So, but what do you mean by all these things? How this affects you as a developer? So these are very important things. And now if you come back and to the editor, so you say you have 1 gigahertz of processor, it means something. So it's frequency. And what do you mean by frequency? It's cycles per second, right? So here we measure it as instructions per second. So this simply means that if you have 1 gigahertz of processor, your processor can execute a certain number of instructions per second. That's what it is telling you. It is telling you some information. It's not just there for bragging or just a fancy word there. It means something. So what do you mean by 1 giga here? So we know what is hertz, it's frequency, instructions per second. So if we can figure out what is 1 giga, and then we'll know what exactly the processor's capabilities are. So what do you mean by 1 giga? It's actually 10 power 9. It's 10 power 9. So if you say I have 1 gigahertz processor, it simply means that it can execute 10 power 9 instructions per second. So if you know that, like that adds to your maturity. So based on that, you can write your programs. You can tell your program how much time it's going to take roughly. So 10 power 9, but again, this is just for understanding purpose. Nowadays, the processors are like dual core or quad core, 2 gigahertz, 2.5 gigahertz, and so on and so forth. But if you can nail down to 1 gigahertz, you can definitely calculate that. So another question comes, what is quad core? It means you have 4 cores parallelly executing the instructions, which means it's 10 power 9 4 times. So you have 10 power 9 instructions executing one core. Such cores you have 4. So octa-core processors are also coming. Why do you need all these things? Because you want to execute your code faster and parallelly. So that's why. So that's what your octa-core processor, 1 gigahertz processor means. It can execute instructions. That's what the whole point of your processor. It can execute instructions, and it can execute 10 power 9 instructions per second. So that's, as I said, it's the heart of your computer. While what do you mean by RAM here? So RAM is random access memory. As the name suggests, it's memory. It saves some data, that's all. The interesting point here is it is temporary memory. If you shut down your laptop, it would be gone, that's all. So temporarily we want to save some data. So you can consider it as your rough book. So you have notes where you want to save it, and that's a disk for future references, and a rough notes. You're not really interested for anything saving, rather you want quick calculations. In that case, RAM is used. So the RAM is very expensive. So that's why you have 8 gigs RAM, 4 gigs RAM, even 2 gigs RAM in the mobile devices in the computer, because this RAM is expensive, while disk is not expensive. The reason disk is not expensive is because it's slow. It's not that fast as RAM. RAM is extremely fast. We need faster memory for calculation and saving the data. So that's why we use RAM, and RAM is expensive. That's why you don't see a higher RAM mobiles. So probably we got like 12 GB or 16 GB mobiles at most, and they are not beyond that. But when you see disk space, it is 256 GB because it's slower and it is less expensive. So as a programmer, you should know the responsibility of these three things. So disk to save your programs, or it can save anything like your videos and audios where you want to access it in future, like permanent storage, or you call it persistent storage. While RAM is temporary storage. You shut down the machine, you lose the data, and you are not really interested to save the data. So that's why it's temporary memory, and it is extremely fast. And then you have processor. You perform some operations, and that operations are actually performed by your processor. So we have Intel processors, we have processors by Qualcomm, and different architecture and all those things we don't get into deep. Definitely when we actually get into the actual sessions, we'll try to see in depth of what is that architecture and all those things. For now, assume that processor is a processor. It executes instructions. So what exactly happens when you write a program? So your processor starts, your entire program is loaded into random access memory, and processor will start executing every instruction and then shows you the output. The output can be in different formats. Maybe it's your web application, or it may be shown on your monitor console, or it may be something else. So maybe you're saving it to some other file, and there can be an input. So this is how usually your typical application is going to be. So you have some input passed, and then the processor takes care of it, RAM and all those things work together, and then finally they produce the output. So these are the basics. By no means they're comprehensive discussions in depth, but for the demo session, I believe this is good enough. Let me know if you have any questions before we move on. Okay, so I assume there are no questions. So let's get into JavaScript. So when we say MERN, don't think that MERN is a new language. So it's a framework. So we actually use JavaScript in order to write application using MERN stack. So MERN is like a tech stack. It helps you write front-end applications and back-end applications, but the programming language that you will use is JavaScript. So if you master JavaScript, learning MERN would be a lot easier. So this course focuses mostly on JavaScript for the first month, and we'll make sure that you understand all the basics and all the nitty-gritties of JavaScript, and then only we'll get into React or Node afterwards. Okay, so first thing, whenever you want to learn any new language, you have to install it. Say if you want to learn Java, you have to set up Java on your machine. We call it local setup. So what do you mean by local setup? You have a local machine and you want to set it up, because this is what you'll do when you get a job also. So when you get a job, say you're getting a job and the job role says that you need to work on C sharp. So first thing, you need to install C sharp in order to do anything. And that you have to do yourself in companies. Yeah, there would be a little bit of help, but nobody gives you a machine which is set up. So that is expected from you. You should know how to install software and you should know how to set up your machine. So mostly you do it yourself. So when it comes to JavaScript, luckily we don't need to do any installation. So I'm in Chrome browser. The only thing I need to do is hit F12, the function key 12, and bring up this console, and this has JavaScript engine installed. So every browser has JavaScript engine installed. We don't need to do anything further to install JavaScript. So this is your JavaScript playground. Here, just type something, you will have it. So if you want to learn how to print hello world, you just say console.log hello world. Console.log is similar to system.out.println in Java, where we say system.out.println hello world, if you know what is Java. But if you don't know it, that's fine. And we call it output statement. So that's the first thing that you're learning today, console.log. So printing something, the output is printed here. So pretty much you can do anything here. Say you want to add two numbers or negate two numbers, you can just do it. See, it is calculating and it is giving. So if you want to declare a variable is nothing but a memory location. You want to save something temporarily. Say A is 10. So what exactly happens here is there would be value 10 and that would be saved in your random access memory, and you can access it using A. Just like you and I have names so that we can be referred, our variables will also have name so that we can refer it in future. So if I want to print that A, I'll say console.log A, like that. So what exactly is happening here when I say this? It actually loads the program into RAM, and then it allocates the memory, and then if there are any operations, your processor would process them, and the output would be on the console. So if you see A equals to 10, not exactly the value 10 would be saved in your RAM. You cannot save 10 on RAM. The reason is your computers work on binary number system, not on decimal number system. Humans, we are familiar with the decimal number system where the digits would be 0 to 9. So if you want to represent any number, it would be from 0 to 9. So if I want to say 10,500, I'll say 10,500. If you see the digits, it would be from 0 to 9, no special digits, nothing beyond 0 to 9. Any number you can form it. But when it comes to computers, they deal with binaries. The only digits that are allowed is 0 to 1. That's all, either 0 or 1. So when you say 10, this would be converted into binary first. So how do you convert that? So yeah, definitely you have a system to convert a decimal number to binary. You can, of course, probably you already know that. But anyway, we don't get into deeper for now. So 1010 is the number equivalent to 10 in binary, and this 1010 would be saved on your RAM. So why does this? Why it actually saves? Actually, in most of the languages, your integers are 32-bit binary numbers. So it is actually saved something like this. How many bits we have? 16. Actually, you have few more like that, like this. This is exactly how your number is saved on your RAM. Because integer is a 32-bit number, 32 bits are used for representing an integer, and this would be converted. Of course, the remaining bits are useless, they are empty, but still, because the integer size is 32-bit, and this is what would be saved on RAM. Why do you really need to say that in binary? What? Yeah. So what's the reason behind going and saving the data like this? It's because that's how your RAM is built. That's how your uh, uh, RAM saves the data. So it actually has something known as tiny transistors. Say I'll represent this as a, say this is a transistor. So something like this you'll have billions of these transistors. So this transistor will have only state yes or no, or true or false. True is represented with 1 and false would be represented with 0. So if you want to save number 10, to keep this demo simple, so I'll just go with 4-bit system, not 32. So what actually happens is 10 would be represented as, let me pick a brush here if I can. So 1010 would be represented. You need to choose the color. Yeah. Yeah. So 1010 would be represented like this. This has true, and this is true, and the remaining are false. So this is exactly how your computer represents a number, this transistor. So what do you mean by this red color? It is actually power. So transistor, if it contains the electricity, which means it has digit 1. If it doesn't, it has digit 0. So yeah, as a programmer, you don't really need to know all these things. But as I said, if you know them, that will actually make you more mature programmer. This is how exactly the data is saved. So if you want to just save one integer, you need 32 transistors to do that job, just for saving one variable, because it is 32-bit. You have other data types like long that takes 64-bit, so you need 64 transistors in order to save one information. Yeah, that seems like a lot, but these transistors are small enough so you can fit them on your mobile device. They're very small, like you have billions of transistors and they are doing their job, and you are able to definitely not worry about all these things. And you are just saying simply var a equals to 10. When you say this, yeah, behind the scenes, a lot of things are happening, but you don't really pay attention that much. Knowing this is very good, but as a programmer, you don't really pay much attention. Okay. Any questions on this? So what exactly happens when you declare a variable? So this concept is not specific to JavaScript. It is for any language. It doesn't really matter. Say Java, this is what happens. C#, this is what happens. So the languages, the syntaxes are different, but concepts most of the time, they are same. So if you want to learn any language, you should master on the concepts of language, like variables. So variables in any language are same. You should master on data types. You should master on what are functions, what are objects, all those things. No matter which language you take, the only thing that changes is the syntax, because every language has its own syntax. So you can easily, so if you know one language, learning another language will not take a lot of time. Probably in 1 week, you will know all the basics of a language. So if you know Java, learning C# will take another 7 days, that's all. Because very similar. All the programming languages are built on some concept. So if you are from computer science background, if you are done with probably your third year of your BTech, you'll know there was one subject, PPL or CPL, concepts of programming language or principles of programming languages. That's what that subject is. They talk about how similar languages are, how the principles are same, and the syntax is different. Anyway, so let me know if you have any questions so far before we get into another topic. So what is the takeaway that we have learned so far? I'll just quickly summarize. So you know what is processor by this time, and what it is used for, and how do you measure the processor, what is gigahertz means, and what do you mean by 1 gigahertz processor, and what is next? You have learned console log statement, and you have learned variable declaration and initialization in JavaScript. Yes, any questions? I see someone unmuted themselves. Okay, so I assume no questions. Okay, let's go ahead and simply write one program, very, very simple one. Say you have two variables, 10 var b equals to 20, like this. You're saying that, don't worry about this undefined, just ignore it for now. So A, you're saying that 10. So you're saving this 10 on random access memory and you're calling it A, that location. And you're saving value 20 and you're calling it B. Same thing happens. It would be converted into binary, and then the transistors would be, of course, some transistor will have electricity and some will not have based on its binary representation. Because states are only two, either 1 or 0. 1 means electricity, 0 means no. So based on that, your number would be uh, allocated, or you can identify your number. Okay, so if you want to add those two numbers and save it, we use an operator that is plus. So as I said, most of the time, the programming languages do two things. They save the data and they perform operations on the data. So first two lines, they are saving the data. And the third line is performing some operation on the data. So you're adding these A and B using this plus. Plus is an operator, and whatever I'm doing is an operation. So we call this operation an arithmetic operation because it's arithmetics. So adding, removing, multiplication, division, all these are called arithmetic operations. So I'm performing some operation and I'm saving back this C back. So I'm just going to switch off the annotations so that you don't accidentally can use it. Right. Okay, so C equals to A plus B and performed it. And finally, if I want to print it, I can print it. This is how a typical program looks like in JavaScript. Simple thing, you have added two numbers and you have your output, you're printing it. So if you consider this, processor takes all these instructions and try to execute it. So this is, say, one instruction, this is another instruction, and this is, although it looks like one instruction, it is not. Actually, what happens, processor picks this one, so it goes and takes the value of A, and it goes and takes the value of B and then saves it in C. So it is not exactly one instruction, it is complex, it is more than one instruction, like that. So if you have 10 power 9 such instructions, this program will take 1 second to execute on 1 gigahertz processor. That's how you calculate. That's how you know how to relate your program to the processing power. So 10 power 9 instructions you have, it takes 1 second to execute the entire program. Of course, we don't have 10 power 9 instructions. 10 power 9 instructions are a lot, but I'm just giving you for the uh, information sake. Yes, will there be more than 10 power 9 instructions in a program? Yes, complex programs will have definitely more than those instructions, and programs would be sometimes slow and sometimes they would be fast based on the things that you're doing. Anyway, so let's not get into deeper into performance. So far, the takeaway is, how do you measure the processing power and how do you relate it to your uh, program? So what happens in the interviews, they'll ask you like, how does your program performs? If you can improve it, we call it performance improvement. And if you can relate this with your processing power, definitely that would help. Okay, so the next topic that we will discuss, so we have 8 more minutes until we stop the demo, but let's see if we can cover a couple of more topics. So the topics that the next that I'm going to cover, very basic. So far you know what is a variable and how to print it and how to perform a simple operation like plus or addition. So the next topic we will see is a function. So function is nothing but a bunch of statements that you put together and you name it. That's all. So I'm creating add function, and the same program which I've written earlier. So what I'll do is I'll try to say var a equals to 10, var b equals to 20, var c equals to a plus b. Two variables, I'm adding them, and then I'll print it. That's all. Console.log C. So this is what a function means. So you're adding it. It will not execute unless you invoke it. So now if I want to invoke it, I have named it, right? I have given a name, so I just need to say add. I can call it as many times as I want. That's the advantage of your functions. Just say add, you can call it a million times. You have written once and you can invoke it as many times as you want. So that's the advantage of functions. You can reuse them, you can call them as many times as you want, and you can group some certain number of statements. Functions are not a necessity in JavaScript. Without a functions also you can write your code, but it's a good practice to keep your code, related code in one function. So with that knowledge, so let's go ahead and try to write a subtract function. Say you have subtract, I'll say var a equals to 10, var b equals to 20, something like that, and then I'll say b minus a. The new operator that we are seeing is minus. And then I'll just print the output using console log statement, and then I'll end the function definition. So this is called a function signature. Say you have a name of a function, and there would be something known as parameters. They all are called a signature of a function, and this is called a body of a function. So the body of the function needs to be wrapped inside braces. These are called braces. So brace starts and brace ends, and this is called body. Two things, signature and body. So save this and call this method as many times as you want. Definitely you get the result. But if you have noticed, the result is not really appealing. It's not dynamic. It is static. No matter how many times you execute subtract function, it is going to give you the same output. And that is not a really good thing to do in programming. Your program should be dynamic as opposed to static, because you have written, say, it's like you are building a calculator, and that calculator, what it does is it adds or subtracts only these two numbers. No matter what numbers you pass, it will only give you the output 10. So what is the problem with that calculator? It is virtually useless. You can't do anything with that. It's a toy, nothing beyond that. It just subtracts 20 minus 10. That's always. But if you want to make this function dynamic, what you should do? You go a step forward. So let me clear this. Okay, say I'm creating another subtract function here. So you pass them as parameters. So I'm going to write the code again. The code is slightly different than what we have seen earlier, and then I'll print it. This time I'm not assigning the values to A and B, but I'm asking someone who is calling it to pass it. For now, I'll say 100 minus 120. I'll get it. And then I'll say 210. I'll get the result. And I'll say subtract 10 comma 20. See, for different inputs, it is behaving differently. And this is what dynamic function looks like. And this function is more usable and more helpful than the earlier function with the hard-coded values. It has only a equals 10, b equals 20, that's all. What it does, it will always returns you 10. No matter what, the output is always going to be the same. But if you just parameterize it, we call A and B, instead of calling them variables, we call them function parameters, because this function is expecting them. If you dig deeper into it, they are still variables. They are called still local variables, but they are a little bit of special variables. So we call them parameters. So how many parameters you can have? You can have 0 parameters. You can have 1 parameter. You can have many parameters. Doesn't really matter. A function can expect or can accept as many parameters as it wants. Of course, having a limit is always a good idea. In companies, in product-based companies, usually you will not have more than 3 parameters, because if you have more than 3 parameters, it becomes hard to read. So that's why they'll have a limit. But when you see JavaScript will not mind if you put 100 parameters also. What happens if you write 100 parameters? You have to pass them 100 here, and that would be a hectic job. So usually you will not have more than 3 parameters in any function, just to make that program more readable. Okay, so apart from this, there is one more concept related to functions. So instead of printing it, what you can do is, you don't worry about printing it. You can something known as return. You can do return. So what this does is, it doesn't print it, rather it returns it. It calculates and returns. So how do you catch the return value? You'll say res, subtract, you pass some values, and the result will have now 10, like that. So this is how you catch it. So what's the advantage of returning it? Because when you write an application, sometimes you may be writing an application for mobile and web, two of them. So on mobile, the printing would be different. On the web, the printing would be different. So that's why the subtract function will not worry about where to print. So what it does is it just returns. So it takes parameters, input, it calculates, and it returns. So your functions are nothing but a mathematical concept. This function concept is not coming from computers. It is coming from mathematics. So mathematics also has functions, and the function takes input and it can do something, and then function returns something. So in mathematics, every function returns something, and it is only one value. Function returns only one value. The same way here in programming world also, function returns only one value. So most of the concepts definitely are coming from your mathematics, like integer. When I say integer, integer is a mathematic concept. So type of data that you save is an integer, or it's a decimal, a lot of others. So all those concepts are coming from straight mathematics. So before you get started with this course, it's a good idea to just brush up your mathematical skills a little bit. So one more thing is, the more smarter you are in mathematics, the more smarter you'll be in coding, because coding is definitely an extension of your mathematical skills. Your If you are logically good, if your logical skills are great, you'll be a great programmer. So it's a good idea, just go and spend some time and try to make your mathematics, or brush up your mathematical skills before learning any programming language.